Okay, I'd like to try my presentation in English. So I'm Shoji Yamada at International Research Center for Japanese Studies, or Nichibunken, a member institute of the National Institute for the Humanities. Yes. Actually, it's first occasion for me to come both Sofia and EAJRS. So I'm very glad to see you all. I am pleased to address the advancements made by our institute, Nichibunken, in the realm of the digital humanities. I will focus on releasing the Nichibunken Digital Archive, NDA, and using artificial intelligence to enhance database functionalities. These steps help us access more cultural resources and analyze historical data in new ways. So this is the topics of this talk. The first topic is Nichibunken Digital Archive, and next similar text search for Yokai DB. And next is Kojiruyen full text DB and AI translations and conclusions. First, I'd like to talk about our new digital archive. The Nichibunken Digital Archive, launched in March this year, represents a leap in the accessibility of image materials. This archive is designed to be IIIF compliant, enabling high quality image access and manipulation. It is based on the Mirador browsing interface, a powerful tool that supports viewing and analyzing images. This archive supports Japanese and English interfaces, broadening its usability and ensuring non-Japanese speakers benefit from these resources. However, the metadata provides romanized titles and that are not fully translated into English. So far, the NDA hosts 1,499 items in 3 collections, each offering unique insights into Japan's rich cultural history. They are Yoshida Hatsaburo Bird's Eye View Maps, Emakimono, and Folklore Illustrations databases. Let's explore the significance of these collections and what they offer to researchers and enthusiasts. Okay. Yoshida Hatsaburo Bird's Eye View Maps. This collection includes high-resolution images of bird's eye view maps created by Yoshida Hatsaburo and some of his contemporaries. These maps are artistic masterpieces and valuable historical documents that provide a detailed view of urban and rural landscapes in Japan from the late Meiji to early Showa periods. They capture the architectural changes and landscapes of the era, offering a window into the past, and that is both informative and visually captivating. The next one is Emakimono. The Emakimono collection features detailed digital images of traditional Japanese picture scrolls. These scrolls are rich in narrative and artistic detail, depicting historical events, folklore, literature, and cultural practices. They are an essential resource for understanding the storytelling traditions and visual culture of Japan. High-resolution images allow researchers to examine intricate details, brush strokes, and color usage, which are critical for art historical analysis. The third one, folklore illustrations. This collection contains high-resolution images of illustrated storybooks, ezoshi, and printed illustrations from the Edo period. These materials are also as significant as emakimono for depicting everyday life, customs, works of literature, and beliefs of the time. They provide a fascinating look into the popular culture of Edo period Japan. In addition, we will expand the bird's eye view maps images and add 2 more collections. They are Chirimenbon and Namazue to the NDA very shortly, perhaps next week or 2 weeks later, I don't know, but shortly they will come. Let me show you an example using emakimono collection. When you click the collection, the list of titles appears. If you pick the Ino Yokaiden emakimono, you can scroll and zoom the picture scroll in mirror door interface. Ino Yokaiden, this scroll illustrates the tale of a samurai who endures encounters with both fearsome and humorous yokai for 30 consecutive days. The triple eye technology allows you to zoom in and out as well as scroll through intricate depictions. In my opinion, these triple eye functionalities are particularly well suited for browsing Japanese picture scrolls, as they enable users to closely examine the narrative flow and artistic details. We have started connecting previously opened databases to the NDA. Nichibunken's yokai image database, which was opened in 2010, includes 4,317 yokai images clipped from digitized materials. We made links from the clipped images to the high-definition images on the triple eye image server. You can browse the originals of 3,363 images out of 4,317 in Mirador Viewer. When you open the viewer, first appears the whole material and automatically zoom in the clipped yokai. So researchers can examine the context of the yokai in the scroll or print. So what you now what are seeing is the image from なんだっけ、化け物尽くし絵巻。The colleagues of my institute brought full-size digital copy of this emakimono today. So maybe tomorrow they can see the copy. To implement this function, say the connection between the previously open database to new IIIF-based database. To implement this function, it was necessary to identify the location of the previously clipped yokai within IIIF canvases. For this purpose, I initially employed template matching to successfully detect the coordinates for approximately 2/3 of the target images. For the remaining approximately 1,000 images, I developed a custom tool to acquire rectangle coordinates on the IIIF canvas, which is different from the coordinates on the screen. This tool operates by allowing user to input the manifest URL and the canvas number. Sorry for where it's very small characters, and I can't point the area where I'm talking now. So this tool is it's at the head of the interface. You input the manifest URL and the canvas number. Users can then locate the yokai by zooming in on the image. Once the yokai is visually identified by your eyes, users select a rectangular area surrounding it. Then generate the XYWH coordinates for the yokai on the IIIF canvases. Additionally, it enables users to download the high-definition image directly from the IIIF image server. This tool would be useful for librarians and researchers involved in IIIF projects. For those interested, the tool is available on GitHub, shown in this slide. Before the release of the NDA, we provided various image databases, which continue to be accessible in their original forms. Notably, the Bird's Eye View Maps database was designed with IIIF from its inception. For the Emaki Mono and Procura illustrations databases, we have incorporated links to IIIF manifest files only. However, the image files in these databases remain separate from the IIIF service. Consequently, the current system structure exhibits some redundancy. Okay. An ideal future system will encompass additional collections and resources, thereby expanding the scope and value of the archive. By integrating a broader array of databases, the system will offer a more comprehensive platform for both researchers and enthusiasts. This expanded integration will facilitate interdisciplinary studies and encourage discoveries, enhancing the overall utilities of the archive. So the next topic is about the discussion in the implementation of a similar text search function for the yokai database, which utilizes machine learning technology to enhance database search capabilities. Yokai is featured in a multitude of folklore stories. The Nichibunken yokai database comprises 35,257 reports sourced from folklore journals, prefecture-level official histories, and essays from the Edo period. This database includes bibliographical details and summaries of these reports. The central image is result of the search for the yokai database. And then, given the diverse range of stories contained within the database, researchers often need to identify similar yokai phenomena across different reports. The right window is a current window of the similar text search function. This slide illustrates how this capability facilitates such searches. In practical terms, this function enables researchers to select a description of a yokai and obtain a list of similar texts from the database, even if the wording varies. This capability greatly enhances research efficiency and accuracy, facilitating more comprehensive studies of folklore and its transmission. To implement these functionality, we employed a TF-IDF vectorization to calculate text similarity. This method allows for identifying and comparing similar descriptions across various reports, thereby improving the analysis of folklore data. The TF-IDF approach quantifies the significance of words within individual documents relative to the entire corpus. The process begins with extracting nouns, verbs, and adjectives from all descriptions. We then compute the TF-IDF values for each word and vectorize the text. The similarity between the two texts is subsequently determined by using cosine similarity value. So in discussing the TF-IDF method, which many of you may recognize as a classical approach, a common question arises. Why are text embedding methods not being considered? We must note that we did explore several representative text embedding vectorizations, particularly those offered by leading generative AI companies. In our analysis, we compared text embedding models developed by OpenAI and Cohere with the TF-IDF approach. These models were assessed for their capacity to match similar yokai stories. These text embeddings can enable more nuanced and context-aware comparisons, potentially surpassing traditional methods in terms of accuracy and relevance under specific circumstances. However, contrary to our expectations, subjective evaluation did not reveal a clear superiority to the text embeddings. In the case of this short sentence, all three methods, OpenAI's, Cohere's, and TF-IDF identified the same text as the most similar. The next example came from Toire no Hanako-san folklore. Regarding this text, TF-IDF selected the text that appear to be the most similar to the query text as far as our subjective evaluation. And the third case, however, in this case, both OpenAI's and Cohere's models identified the same text as most similar, seemingly surpassing the result obtained through TF-IDF. As illustrated in these slides, our findings suggest that the fee-based models offered by AI companies did not demonstrate clear superiority over the free TF-IDF method. Nonetheless, conducting a more detailed comparison is crucial to reach a definitive conclusion. Okay. Then move to the third topic, next topic. Quadrillion full text database and AI translation. Okay. With advanced AI translation tools, people might access and comprehend classical texts without extensive training in classical Japanese languages. This development democratized access to historical documents, enabling a wider audience to understand Japan's rich cultural resources. Nichibunken has been actively developing the Kojiruin full-text database, an extensive compilation of Japanese cultural terms dating back to periods before the Taisho era. This encyclopedia was initially started by Meiji government, say Monbusho, and accomplished by Jingu Shicho. So the Kojiruin, this book is a very useful resource for understanding Japanese cultural history, has a potential to benefit from recent advancement in AI technology greatly. Currently, the database includes a full text of 20,704 pages out of 67,206. The content is written in a complex mix of kobun, kanbun, and kanbun kundoktai, posing significant challenges for modern readers. The benefits would be substantial if AI can effectively translate these texts into modern Japanese and other languages. Such translations would not only enhance accessibility, but also allow a broader audience to engage with this valuable cultural resource, thereby contributing to the understanding of Japan's cultural terms. Experiments with automatic translation into modern Japanese using large language models, such as GPT-4o or Command R+, and Cloud 3.5 Sonnet, have produced notable results. These models were tested on various passages, translating complex classical text into modern Japanese with a fair degree of accuracy. For instance, a passage describing a record from Bunsei 6 was translated effectively with the AI models, preserving the original meaning. So, ChatGPT-4o translated this text into リン氏が語るには今年の、ちょっと読めないです。すなわち、文政6年10月8日の夜、it's completely, I think it's very fit to the original text meanings. The next example, however, we observed some mistranslations and not definitive interpretations of a term whose meaning remains unclear, such as Nichiju, it's green lines. ChatGPT translated Nichiju as 太陽が2度昇る。Command R plus is 太陽が二重になって見える。Cloud 3.5、太陽が複数出現したり。And so yellow lines are seemingly mistranslation or hallucinations. The third case, the third example involved the translation of a famous waka poem by Kisen Hoshi. In this case, the translations exhibited some hallucinations and mistranslations. The red marked part is seemingly hallucination. The original text is Oyashira's Kisen Hoshi, but ChatGPT completely ignores the first two parts. Command R plus mistranslated Kisen Hoshi as キーの国の奉仕。 And yellow marked parts are the mistranslations. And notably, a Cloud 3.5 Sonnet provided a more accurate and descriptive translation than the other models. These recent experiments provide us with considerable optimism for the future development of generative AIs. I am confident that as these models continue to evolve, they will achieve even greater precision in translating classical text. This progress holds significant promise for making historical and cultural documents more accessible to a broader audience, and thereby enhancing our understanding of these valuable resources. In conclusion, the advancements in the Nichibunken digital archive and integration of AI technologies signal a future in digital humanities. These developments will ensure that valuable historical resources are accessible to a wider audience. As we continue to develop and refine these technologies, we can anticipate a richer and more interconnected understanding of Japan's cultural materials. Thank you for your attention. I look forward to hearing your valuable comments. Thank you very much.